Now let us consider a reaction in case of nitration of phenol NO2 plus a mixture of concentrate nitric acid, that is concentrate HNO3 plus H2SO4 at a temperature of 50 to 60 degrees centigrade. The compound formed is 2,4,6 trinitrophenol. But if we nitrate chlorobenzene Cl, the same nitrating agent, the compound formed is a mixture of orthonitrochlorobenzene plus paranitrochlorobenzene. Okay. But again, chlorine is more electronegative than carbon, so chlorine will shift the bond pair electrons towards itself, so it is deactivating group. It has minus a inductive effect, so it supposed to be a meta orienting, but here it is acting as ortho para orienting group. Okay, so why that happens? First of all, which in case of phenol, delocalization occurs. Delocalization of lone pair of oxygen occurs into the benzene ring. How it happens? In benzene, 6 carbon atoms are there. All have alternate double bond and single bond. And all have a hydrogen atoms pair present. And here, in case of phenol, here oxygen is present, and with oxygen and hydrogen atom is also present. Now here the oxygen has lone pair electron, and that lone pair electron present in 2p orbital. And in case of carbon, as it has formed 3 sigma bonds, so it is sp2 hybridized, so pz orbitals remains unused. So here the pz and this p orbital present in parallel position. So here this one is from 2p orbital and this orbital is also a 2p orbital. So here 2p 2p lateral overlapping occurs, and that's why a double bond is formed. When here a double bond is formed, this pi bond shifts to this to make this double bond, and it shifts to here, and this pi bond ultimately forms a negative charge with this carbon atom. That is how this lone pair gets entered into the benzene ring through resonance. Here double bond occurs as it is due to lateral overlapping between a 2p orbital of oxygen, a filled 2p orbital of oxygen with another 2p orbital of carbon. But in case of chlorine, when it is attached to benzene, when chlorine attached to benzene, let's see what happens. Here hydrogen, 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 and here chlorine. Now this chlorine has also a lone pair, and this carbon also has a pz orbital, but this lone pair is in 3p orbital and here it is in 2p orbital. Due to energy difference between two orbitals in different energy level can make a head-on overlapping, but when a lateral overlapping occurs, they must or they should have in same plane. if they have different, if those orbitals are in different energy level, in case of 2p it is in lower energy level and in case of 3p it is in higher energy level, so lateral overlapping is not effective. Okay, that is why this delocalization is very poor. In case of phenol or in case of aniline, oxygen or nitrogen, the lone pair of nitrogen is also in 2p orbital and in carbon it is 2p. So in case of aniline, the lone pair can easily get delocalized into the benzene ring, as here 2p lateral overlapping occurs between nitrogen, lone pair of nitrogen and the carbon. 2p orbital of carbon. In case of aniline, in case of phenol, delocalization is very effective, but in case of chlorine still have lone pair electron, but that lone pair is present in 3p orbital. So here the energy gap is there between the 3p orbital of chlorine and the 2p orbital of carbon. So lateral overlapping is not so effective, and that's why delocalization is also not so effective. That's why chlorine cannot activate benzene ring in such extent that 3 electrophile may come at once. As we see in case of phenol or in case of aniline, the delocalization of lone pair of nitrogen or oxygen makes the benzene ring highly electron rich or highly effective or highly activated towards the electrophilic substitution reaction, so that electrophiles may come at once in every possible positions or in every available positions. But in case of chlorine, no such happens, no such factor is there, as the lone pair cannot get effectively delocalized into the benzene ring. So lone pair cannot activate the benzene ring in such extent. Okay.